Hi everyone, so I'm going to be going over a few different design patterns you can use in object-oriented programming, just explaining them and then showing a little example in Visual Studio as to how they work and how they can be implemented. So the first one that I'm going to be looking at is the Singleton. So the Singleton is a class object that it can only be instantiated once. So every time you call for that object, you call for a new instance of it, it will return the same one. So throughout your entire program, there can only exist one of this object, and whenever you change it or interact with it, it will change it anywhere in the program. So why would you use it? You would use it instead of passing around an object. So instead of having all of your classes passing an object around, each one can just call for it, take it, change it, and then discard it. So it means you don't have to be passing everything around, and it reduces coupling. So it reduces the parameters in your methods. So how do we use it? So how we actually create it is we need to create a class which has a private constructor and it holds one of itself. So as you can see here, we have the private constructor and then we have a public get instance, so it's a read-only property. So the instance is here, private instances. Read-only, so we can only get a copy of it. So what this does is it says, get the instance. If it doesn't exist, create one. If it does exist, give me that one. That's it. So you probably think this is very similar to a global variable, which is dangerous. Global variables are bad, and it is very similar to that. So it's a bit controversial to use it, but in some instances it makes sense. If you're creating a program that will only ever have one of that object and will never have more of it, and once you put this in, it can't have more of it because you have to go back and change everything to remove the singleton. So let's have a go at actually making one. So, the first thing we're going to need is, in this blank program, is a singleton class. So, okay, if we create a new class, call it singleton. Alrighty, so we make it a public sealed class. So it'll have a private static so this is the property it has of itself, the one we're going to make read-only. We'll also have the private constructor, if I can spell it. Oops. And we'll create a variable so that we can manipulate it, so we can easily see that it's actually a singleton. just be a simple integer, nothing complicated. Alrighty, so then we need the instance read-only property. So make it public, static, call it instance. So you can say down here, get now here's the part where it really becomes interesting. So if instance is not equal to null, in other words, it exists. So if the instance exists, we return the instance. And if instance does equal null, then we create a new instance and return that. Sorry, if we have one, we return it. If we don't already have one, we create it. Alright, now there's one more thing to remember in this part, is that you do have to make it thread safe. So how we do this is just good practice, is we create something called a lock or a bolt or a key or whatever. There's a few different names people use. So this is really important for making sure that it is thread safe. So it's a private static read-only object. It's just an object. So down here, when it's creating a new one, we say lock underscore lock. To ensure you only do actually create one. Very important. So that's that. Then we'll create a quick, we'll do the variable as well, so that we can manipulate it. Just a simple get set. Alrighty. So that is our Singleton. So just once more to run over it, we have the instance of itself that it holds, the lock to keep it thread safe, and this is just a variable so we can manipulate it. Now, it has the private constructor. We have the public read-only property of instance, which either returns an instance we already have, or creates one if we haven't already created one, returns that. And then we just have the property variable. So now we need some tests to prove that it's actually a singleton. Alrighty, so you're going to find this problem where it doesn't want to create unit tests for private classes. So what we do, just quickly, cheeky, make this public, create unit tests, and then we go back to the single and make sure this is private again. Cheeky, but it works. So, what tests do we need to have? So, we want to check that if we create two instances of the singleton, they're the same. So we can use that. So what do we want to test? Well, we want to test whether we create two instances of the same object, they are the same object. Not identical, not two singletons, one singleton. So how do we do that? So in the unit tests, we have what's called our same, not our equal, our same. So that's what we can assert first. It can be our first test. So if we create a singleton called single1 equals singleton dot instance, and now do that again, single2. Awesome. So now you'll notice we haven't used a constructor as normal because we can't access private. So we have to use dot instance that gets the get read only property. Alright? Very important for when you're actually doing it. So now we can check that single1 is equal to single2. Green. Beautiful. Alrighty. So now let's do another test. Oh, I should change that. So now, from another test. So because we created that variable before inside the singleton, what we can do is we can show how useful this can be. So if we have single1 and a single2, now we change single1 dot variable and make that equal to 999. Why not? So what we're doing here is we create two different singletons, and then we change one of the properties in the first one. Single one now has a variable equal to 999. If these are two different singletons, then single 2 hasn't been changed. But because this is the same instance, they're both been changed. So what we can say now is our equal. So single 2's variable is now equal to 999, even though we didn't touch it, because it's the same one. Beautiful. So the other thing that we mentioned before is you can't use the constructors private. Let's test it. Let's prove that. Let's show that that's true. So singleton single equals new singleton. There we go. Can't access it. It's private. Can't be done. Doesn't like it. Won't work. We can use the .instance. So using the .instance will return us an instance of this singleton. Alright, and that's pretty much it. You definitely have a go at doing this. Definitely a fun pattern to have a go at. Alrighty.